Hi, hello friends. Welcome back to my channel. In this video, we are going to learn one of the important concept in mathematics, that is surds. Easy concept as well as important also. And this concept which we are going to learn today will be helpful for Hstr exams, Gpstr exams, TET, central TET exams also. If you are a school going student, no problem. It will be helpful for your 10th standard public exams also. Okay, before moving to the video, if you are new to the channel, kindly do subscribe and press the bell icon so that you will get the notifications of all the videos we upload here, which will be useful for all these exams, competitive exams like Hstr exams, Gpstr exam, TET, central TET exams, KV exams, CRIS, and all these exams also. In our channel, we also take up mental ability concept and mainly of maths and science concepts we handle here. Okay. We shall move to the concept now. Surds. An irrational root of a rational number is called a surd or radical. Okay. So we have learned about this basic concepts of rational number, irrational numbers in the previous video. Kindly check the channel description box. You will get the link of the previous video. If you have not watched, you can kindly watch it. Or if you are aware of these numbers, then we'll just move ahead. So talking about rational numbers, any number which can be written in form of p by q or x by y, fraction form. Okay, so where denominator is not equal to 0, we call it as rational number. Okay, 3 by 4 rational number. And moving to irrational number, if it cannot be written in form of rational numbers, that is if it is a square root form mainly, which cannot be simplified further. Square root of 3 we call it as irrational, square root of 5 irrational. Okay, all these basics we have learned. So talking about surds, it's an irrational root of a rational number. Okay, so consider if x is a positive rational number and n is a positive integer such that x to the power of 1 by n, so that can be written as nth root of x, right? We write like this. If it is a square root of x we write. If it is cube root, fourth root, fifth root, sixth root. If it is nth root, we write like this, nth root of x. This is a irrational number. Therefore, x to the power of 1 by n, we call it as a surd. So this is a surd. Even this form is a surd. Okay. So examples are cube root of 6. Here 6 is a positive rational number and cube root of 6 is it's an irrational number. So it is a surd. Square root of 5 is a surd. Fourth root of 8 is a surd. Cube root of 20 is a surd. We shall also check out which are the numbers which are not surds. Few examples we'll consider. We can write square root of 4 as 2 value we can find out directly. So square root of 4 is not a surd. Meanwhile, we'll check out with cube root also. Cube root of 27, example if you take, cube root of 27 is 3. So this is not a surd. And fourth root of 625 is not a surd because the value of fourth root of 625 is 5. Therefore, all these numbers given here are not irrational and they are not surds. Okay. As we move further to few important points related to surds, every surd is an irrational number, right? But every irrational number is not a surd. For example, pi is an irrational number, but it is not a surd, right? When you write the value of pi, we get 22 by 7. That is a rational number, of course. So when you write just as a pi, it's an irrational number, but it is not a surd. Okay. Next, moving to order of a surd. Square root of 5 is a surd of order 2. When you write square root, it is understood there is 2 here, right? Okay. When you write cube root of 11, so order of the surd is 3. When you write fifth root of 7, order is 5. And the elements, the numbers which is inside this root symbol, so those are called as radicand. Okay. Next, moving to types of surds. There are two types of surds, like surds and unlike surds. Like surds, a group of surds having same order and same radicand in their simplest form are called as like surds. These two characteristics must be having, like same order and same radicand in the same group of surds. For example, square root of 3. So order here is 2 and radicand is 3. Next 5 square root of 3. 4 square root of 3. 7 square root of 3. So you can see this square root of 3 is common here. So it is the same order and same radicand they have. Don't worry about this whole number which is present before the surd. No problem about this. But this, in the simplest form of the surd, whatever numbers we find here of the order and the radicand, if they are same, then they are like surds. Next, cube root of 4, 7 cube root of 4, 5 cube root of 4, all cube root of 4 with the other whole numbers, no problem. So these are all example of like surds. Unlike surds, a group of surds having different order or different radicand in their simplest form are called as unlike surds. Example, here square root of 2, square root of 3 and 2 square root of 5. Here order is the same but they have radicand different. Among this any one is changed, no problem, then they are unlike surds. Here square root of 5, cube root of 89, cube root of 14. Neither order is the same nor the radicands are the same. Hence, these are also example of unlike surds. Okay. Moving to surd addition. Only like surds can be added. Example, 4 square root of 2, 3 square root of 2, 6 square root of 2. All are like surds, so you can add them up. Add this whole numbers which is present before the surd. 4 plus 3 plus 6. And square root of 2 is the common here. So square root of 2. The surd you can write here. Add them up. 4 plus 3 plus 6 gives us 13 and square root of 2. 13 square root of 2 is the answer. So you can add them only when they are like surds. In case of surd subtraction, only like surds can be subtracted. For example, 16 root 7 minus 5 root 7. So 16 minus 5 you can write and root 7 common. 16 minus 5 is 11 root 7 is the answer. In surd multiplication, surds of same order can be multiplied. Okay, radicand could be different, but if the surds are of same order, it is square root, cube root, fifth root, sixth root, whatever the root may be. Nth root of A into nth root of B. So nth root of A into B. A into B you can write. If it is square root of 2 into square root of 3, you can write square root of 2 3s are 6 will be the answer. Okay. Next, in case of surd division, when dividing two separate surds of the same order, we can combine them under one root. Example, if it is in the numerator square root of A divided by square root of B, so you can write whole square root of A by B. You can write in surd division form like this. Okay. We shall now move to few sums related to surds. Actually, in the Hstr exam of last year, previous year, that is 2015's question paper, if you look into, there are no questions based on surds. It is in the previous year's 2012's question paper, there are questions based on surds. Okay, so it depends, but it is a very important concept. They may give in the following Hstr exams. We are expecting the questions. First one, simplify 4 square root of 12 minus square root of 50 minus 7 root 48. Okay, so how can you write this 12 as 4 3s are 12, right? 50 as 25 2s are, 48 as 16 3s are. Okay, then we can take out the square root of 4 value is 2. You can take it out. This root 3 remains same minus root 25 value is 5. So root 2 is remaining same. 7 remains the same. 16 root 16 value is 4. So take it out. remaining is root 3. So you can multiply this two whole numbers. 4 2s are 8. So hence 8 root 3. Here 5 root 2 and 7 4s are 28 root 3. So only like surds can be added, right? So you can have root 3 and root 3 with the different whole numbers, or subtraction here you can perform. 8 root 3 minus 28 root 3. So 8 minus 28 you can write root 3 minus 5 root 2. 8 minus 28 is minus 20 root 3 minus 5 root 2. Further you cannot simplify this surd. So this is the answer. Okay, since we are expecting the multiple choice questions only for the Hstr exams, you can skip the step. You can do it in there only with moving fast. Okay, you don't need of writing all this and just explaining whatever it is. Here if you know the direct answer, here 4 3s are 12. So 4 if it comes out, you can get 2. 2 4s are 8 only, 8 root 3. And like that you can just simplify there only. Okay, you don't need to write the steps. In order to save the time, you have to be very fast. Next, moving to next question 2. Root 75 plus root 108 minus root 192. 75 can be written as 25 into 7. 108 can be written as 36 into 3. Next number we can write as 64 into 3. Actually, how to find this multiplication value? It will be of the simplest forms only. Okay, you just multiply. If it is more than 100, you can just multiply with 2 or 3 and see. Okay, if you multiply with 1, of course you get the same number. You can go for the next numbers, 2 or 3. If you go with this, if you divide and see the number which is given here, 192 by 3, so that will give you the number, whether if it is divided by whole number or by practice also you can have. Okay, so 75 can be written as 25 into 3, 108 is 36 into 3, 192 64 into 3. So 25 square root value is 5 root 3 and 36 6, 64 is 8. So here you can find all like surds. 5 root 3 plus 6 root 3 minus 8 root 3. So you can write 5 plus 6 minus 8 of root 3. On simplifying this, we get the answer 3 root 3. Next one, root 12 plus root 50 plus 5 root 3 minus root 147 minus root 32. Again, you can write 12 as 4 3s are, 50 as 25 2s are. This number will be the same, 147 as 49 into 3. 32 16 2s are. Okay. On taking out, simplifying this numbers, square root of 4 is 2, square root of 25 is 5, and this number will be the same. For 49 it is 7, 16 as 4. So you can group the like surds. Root 3, 5 root 3 here, again 7 root 3. These numbers you can take it aside, plus 5 root 2 and 4 root 2. First I have taken this, no problem, you can write. How to simplify this? 5 minus 4 root 2 plus 2 plus 5 minus 7 root 3. On simplifying this, 5 minus 4 is 1. So 1 root 2, root 2 you can write. Here 2 plus 5 is 7, 7 minus 7 is 0, 0 root 3. So 0 root 3, answer will be 2. Okay, if it is in the multiple choice questions, you don't need to write all this, you can directly write the answer. Next, another type of question. 1 by 8 root 50 plus 1 by 6 root 75 minus 1 by 8 root 18 minus 1 by 3 root 3. So same way, you don't worry about this which is given in fraction. Just simplify these surds as usual. How do you do up to this step? Further, you can take this value, square root of 25 is 5. So that will go to the numerator obviously, and hence we get all this step. Group them. 5 by 8 root 2 minus 3 by 8 root 2. That will give you this 5 by 8 minus 3 by 8 of root 2, and this 2 will be under one group, 5 by 6 minus 1 by 3. On taking LCM, you will get, the denominator is of the same, you can just subtract or add the numerator. We know 5 minus 3 is 2, so 2 divided by 8 gives us 2 by 8 is 1 by 4. And on simplifying this, you get 9 by 18, and 9 by 18 you can write as 1 by 2. On simplifying this, 1 by 4 root 2 plus 1 by 2 root 3, you get this answer. Further, you cannot simplify surds of different radicands. Okay, so you will retain this as same. Okay, so hope you might have understood the basic concept of the surds. In the following class, we shall continue with the other simplifications related to the surds. Okay, and rationalizing the denominator is also very very important concept. We shall continue with that, and also we'll check out with the question papers questions which are related to Hstr exam. And related to Hstr exams, according to the previous pattern, if you look into, out of 100 marks, 80 marks is of the concept based and 20 marks for concept pedagogy. So we shall work out the pedagogical questions also related to maths and physics for Hstr exams. And also I'll be uploading TET related question papers. You can check into our channel. If you are not subscribed our channel still, kindly do subscribe and press the bell icon, so that only you will get the notifications of the videos we upload here, which will be useful for your exams. And already the videos which are related to Gpstr exams might be useful for Hstr exams also, which is already we have taken up many concepts from maths and science. Kindly check out the channel playlist, so that only you will get an idea. You can start preparing from now only. So learning will not be a loss, right? Okay, so don't wait for the official notification to be released and then to start the preparations of this exams accordingly. You can start from now. You can learn anytime whenever you are free. Okay. Okay, thank you for watching.